So I have no idea what we're going to do here, but we're going to do something with cookie. We're going to close all this and copy our decode folder, make it 06 cookie, and we'll see what we come up with. It's kind of fun not knowing what you're going to do. And if you're watching this online, the code we're using is at GitHub. Goes to 11, and you can go into the GOLANG web dev, and then the place we're at right here is this route. So 00temp, all that. So that directory. So where would be a natural place to store stuff in the cookie? When we get data, right? Let's store it. And so if somebody fills out a form and we have it being sent over with Ajax, then we could take that and we could store it in a cookie. So basically that's right here. So we have all that stuff and now we want to store it into our cookie. What do? Heck, I guess we have to go look at the documentation. Go doc net HTTP. We look at the index and we command F for cookie, and we see there's set cookie and then there's cookie, type cookie. That's right, type cookie is like a struct, has all these fields. And then set cookie right here is going to take a response writer and a pointer to a cookie. So I could just create my own cookie here, C:= http.cookie, all right, and then I just have fields, name, user data, and that's a string, and value, right? So we have this XP. Well, dang, that comes in and we automatically decode it, and it's coming in on the request, and it's the request body, and that request body we know is JSON, right? We know that's JSON. And what is the request body? The request body is IO read closer, and that means it could be read. What can we use to read something that takes a reader? That sounds like input-output functionality, so go doc IO, input-output, and we're just going to look for a reader, and there are all those readers. And we have read at least, read full, and read full takes a reader and a slice of bytes, and it returns an int and an error, which would be the amount that's read. There's a limited reader. There's read at least. There's copy. Type reader. Limit multi-t reader from rune reader section reader. I don't know, IO reader. Read full. Read full. Read full. Read full reads exactly length buff bytes from R into buff, and it returns the number of bytes copied and an error if fewer bytes were read. The error is EOF only if no bytes were read. If an EOF happens after reading some but not all the bytes, read full returns ... Example, strings, new reader, here's some string, cool, that's R. Make, slice of bytes, 4, and that's buff. And then read full into buff, and then print buff, and it will print sum. And error unexpected in a file. So when do we get where do we get unexpected end of file? Read full returns unexpected in file. And if an EOF happens after reading some but not all of the bytes, read full returns that. On return n equal length bytes only if error is equal to nil. So you want to try that? Let's try that. So I have my R body, which is a reader. Read full is going to give me n and an error. So n and error, := IO read full. And that's going to take R.body. But I've already read body. I don't know if you could read body twice. So we'll see what happens there. Sometimes the read head moves to the end. And then we need that buff bytes. So length L colon equal length r dot body. So that's going to give us the length of the body. I wonder if that's going to give us length, because body is a string. It's a read closer. Read closer. For the server request, the request body is always non-nil, but will return in a file. The serve HTTP handler does not need to. So I'm thinking if I get the length, then I can make that slice of bytes, right? You know, like my byte slice will be equal to slice of make, slice of byte, and then I have my length and my capacity, and that will be length r dot body. If that is telling me how many bytes are in body, because I need a byte slice of that length to put into here, because that takes the reader and then the slice of bytes of the same length that you want dumped in there. And I don't really need in. I don't care how many are read and error has been used up above, so I have to do it like that. And I can just return if there's an error. And return if there's an error. Length body. Invalid argument for length. I wonder if I could convert this to string. That's interesting. We'll see what happens. I guess I am kind of curious in N. And format.println N. Just curious. And length. All right, so now I have my byte slice, and my byte slice is hopefully that JSON. I'll convert that to a string. I think this is wacky and it might not work. http.set cookie, response writer cookie. What do I need? Pointer to a cookie. The address where that cookie is stored. So my response body. I will do this one little thing which I like, and this will get us out of the hole. So I go to GitHub, and I go to GOLANG Web Dev, and I want to know how to read my response body and just get the text. So I'm just going to search this repository for R body. Ooh, gave me all my HTML body. I want R dot body. That's so weird. It gives me body when I ask for R dot body. So let's try this. See if body with that at the end works. Now it gives me all the bodies. And I just want go. So I could click on just go. And there's IOUtil read all body. You just put the response body in read all. And you get your body in an error. Man, what was I using? Read full, IO read full, IOUtil. So we were looking in IO. And we could go to IOUtil. Much easier. Read all. Takes a reader, gives me a slice of bytes. I'm curious, though, if this wackiness would have worked. Now that we have a way out, should we try the wackiness? I think we should try it. So we are in 06. Cannot convert our body type recloser type string, so it doesn't like that. Our body to string. And then it doesn't like the length thing when it's not that. So it's like, I don't know, you're trying to ask me, so let's get rid of all that. Kapow. And we'll do IO byte slice. What's IOUtil give us? IOUtil gives us slice bytes in there. So byte slice error colon equal IOUtil dot read all and r dot body. Oh, how sweet it is to love IOUtil read all. So there's the byte slice. Now that's going to work. What else do we need to set? To access this from anywhere, we need to set path. And we should also set secure, meaning true. And that means it has to be HTTPS, but we don't have HTTPS. And we could do HTTP only, which means you can't access it with JavaScript. The cookie. You can't access the cookie with JavaScript. All right, so let's see if the cookie gets written. Imported.use IO. Yay, localhost. And if we go to catch, nothing. And it shouldn't have written any kind of a cookie. And see, nothing's happening there. But if we go to send, and now if we go back to catch, and we should see something here showed up because we sent it, received it. And now if we go to catch, that cookie's there. That cookie got written. But there's no value. User data value. No value. Oh. Why didn't it store the value? Let's find out. The value should be a string. Oh, we're reading it twice. So sometimes when you've read something, you've already read it. So if I took this up here now, now it wrote it. And now when it tries to read it, it says I'm already at end of file. It's like a read-write head, you know, on a record player. The read head on a record player, right? It's already got to the end of the file. You have to pick it up and set it back to the beginning. Or you need to do something like this. So read all, I get my byte slice. Now I have that string, right? So I can now say this is my JSON. My JSON is : string that byte slice. And now whatever I need to do with that JSON, I can do with it. And so one of the things is I want to unmarshal it. Since it's a string, I'm no longer going to use decoding straight from the reader. So I would use JSON dot unmarshal, and I'm going to give it the data, which needs to be a slice of bytes, and then the data structure. So the data is going to be a byte slice, and then the data structure is going to be XP, and unmarshaling is going to give me an error, returns an error. I don't need this here. So there's my data structure, and then down here, since I already have that byte slice, right, I only read it once, I have that byte slice, I can put it here as a string and I can set it. Now it'll work in both places. Does that make sense? Anybody have questions about it? Cool, so I'm going to run it. Send, should be there. Invalid data, invalid byte in cookie value, dropping invalid bytes. Interesting. It doesn't like the double quotes. So guess what you have to do to store that? Remember? Anybody remember? Pulled out of the dusty bin. We just talked about briefly, like just 20 seconds last week. Starts with base. Remember the number? 64. So we can convert that to base 64. And to do that, I'm going to go look at the code sample, and here's base 64. And I would do base 64, new encoding, encode to string, and then that. So it's a package, encoding base 64. So we could go look at the package. So new encoding gives me an encoding, and I can encode destination and source of bytes. Encode to some destination. Encode source using encoding inc. Writing encoded bytes to destination. New encoder instead. Encoder, encoding, and a writer, and write closer. New encoding, encode to string, new encoding, encode to string, source bytes, string. Cool, I like that, encode to string. Okay, so let's add that to our code. So here I have a string, : and it's a base 64, new encoding, and I guess new encoding takes an encoder string new encoding, and encode standard. There's also a constant. Basic for standard encoding, encode to string. We'll go with standard encoding. base64, standard encoding, encode. So that allows you to change it. Encode to string and code to string. Source is a slice of bytes, and my slice of bytes is byte slice. So now I have my string. I just put my string there. So I've now encoded all that, and if we want to see what it looks like encoded, we could print that out. Cool. And Control C. That's what that got encoded as, our JSON. So it encoded it and got rid of those double quotes. And that's pretty wacky looking stuff. It's just stored in your cookie, right? You've seen cookies like that before, right? You're like, I don't know what the heck that means. So check out what we could do now. So if whenever somebody sends the data via AJAX XML, XML, XHR, XML HTTP request, we're storing that in the cookie. So we don't need this up here anymore. So I can take that out, because now the data is stored in the cookie, and we could just put that back right here. And so, you know, if it's coming in as post, it'll put it in the cookie, and then we could check that cookie, and if there's anything there, we could pull it out and put it into the person deal. So how do we check a cookie? We have request cookie, and the name of the cookie, and the name of the cookie here is user data. And request cookie gives us a pointer to a cookie and an error. So a pointer to a cookie and an error. And just looking at my naming conventions here because I have C up above and C down below. And so that means the variables are shadowing each other, and I'm just looking to see if that's something I want. And I think what I want is, you know, if new data came in, I'd want it to overwrite. But that just totally blew up. Because why? This needs to be a pointer to a cookie. Because the one up above is a pointer to a cookie. So I need to take the address there. No loosey-goosey dynamic typing JavaScript crappy wappy here. That's the best line you've heard all night. Right? You got to make sure that your types align. Address is different than a value. So there's the cookie. I mean, isn't this interesting? I mean, it's like a puzzle in some ways. And it's like, you know, taking your little pieces and making sure they all work and they only fit in certain ways. And I don't know, it's fun. So there's I get my cookie if it's there. I have my pointer to a cookie up there. And if it changes with post, then that's great. And with my cookie, I have some data in that cookie, if it's there. I'm just wondering, right? Remember that code we were doing when we were first learning cookies? Let me just bring it up. Cookies. In sessions. If error is not nil, then we created that cookie because it meant the cookie didn't exist. But up here, we're asking for it. And the next thing we want is if the cookie exists. So if we ask for the cookie and it doesn't, if it's not there, then this function's gonna stop right now, so that's not good code. Cookie returns the name cookie provided in the request, or error no cookie if not found. Right? So error no cookie if not found. So do we want if no cookie is found, do we want to end this function? I don't think so. It just means there's no cookie. So why would we want to check that error there? We look for the cookie, and if it's not there, big deal. If error is not equal to cookie, should we do something? I think so. If error is not equal to cookie, right? So if the error is not equal to no cookie, meaning there is a cookie, and let's get the data out of it. Is there a better, that's kind of convoluted. Is there a better way to code it like, hey, there's a cookie, let's get the data out of it? So we could do that one, or we could just do if error equal nil, meaning there's no error. Why isn't it like that? Error equal nil is used as value. Thank you. Right? So that means there's a cookie there because there's no error. Is that right? Because otherwise we get the error. So if error is equal to nil, there's no error. Let's get the data out of the cookie. And we have c.value. And c.value is going to be some base64, right? Remember that came in, that's base64. And so now that we have base64, we need to bring it back to not base64. So let's go look at base64. And what do you think from this here will bring us from base64 back to either a slice of bytes or a string? There's some constants and variables. Standard padding. Variables, raw standard, standard encoding, URL encoding, new encoding. I was thinking there might be standard decoding. Standard encoding is new encoding, encode standard. So we had new encoding, and in here we had encode standard. And encode standard All right, so how are we going to do it? When I look for decode, and decode string looks good, gives us back a slice of bytes and an error, right? And new encoding encoder string, and here we have new encoding encode standard, and that's standard encoding, which we used before. So we could say standard encoding, which would give us new encoding encode standard. Standard encoding decode string, slice of bytes error. Let's try that. So slice of bytes error colon equal, and it's going to be base64 dot standard encoding dot decode string, and the string is B64, right? Or we could just right here do our C dot value and save a step. Now this is getting like crappy looking code. We have an error check within an error. Font.println error. We could return from there. We try to get a value from a cookie and something happens, so let's check it. Now we have our byte slice. And that byte slice is JSON, correct? So JSON colon equal string byte slice, because that's what we encoded originally. So now we have our JSON, we could print it out. JSON. So now we have our JSON. We want to put that into our data structure. Our data structure is XP, so we could do JSON dot unmarshal data JSON into XP, and takes the data and the interface and returns an error. It has to be pointed to. And unmarshal wants a slice of bytes, so we can just put our byte slice right there. So now we've got our data off of our cookie, which was stored as base64, and we decoded it from base64 back to JSON, and then we took that JSON, we unmarshaled it, and we stuck it into our Go data structure. And now that it's in our Go data structure, right, we could pass that in down here. And we could take this function here, and we could call it get all this. And we'll see what we pass in there. Turn slice person. And once the request. So we need to bring in the pointer to request. So here we'll pass in the pointer to request to users. And now the cookie here needs to be like that since we took the cookie out. And in this one we'll get the users. So now we could come up here and we could do this and pass XP in to that template, and that's send go HTML. Let's just bring this down in size. Guess we could do this. That's fine. And what's happening on index? So this is just going to the standard out. So we can make an index, and we can copy this up. And then on index, let's make it let's see what we messed up. Main go 43. Oh, that's interesting. I don't need this anymore, right? You'll get the user and then encode it, which if it's nothing, that's fine. Or if they're there, it'll encode them. And then put that to standard out. And then where is the... Oh, the JSON. The JSON is only coming from this send, which is right there. That's where we're getting our values. So when I go, oh, let me clear my cookies. Index is wonky because right here I'm sending stuff over to the deal. So do I want to encode there? Why? Send over the values? I think not. This is called a decode example after with cookies. Cool. Nothing. What about at catch? Nothing. What about when I send? We are now going to send data to the catch path. Okay, cool. And we should have down here wacky value for user data. Right, base64. And now what happens when I go to index? Pulled it from the cookie. It's the only place it got it. Right, decoded it from base64, got it into JSON. From JSON, it unmarshalled it into the data structure. And then catch is going to be the exact same functionality. So you saw base64, and you saw JSON, marshalling and unmarshalling. So I want you to each find somebody, or just in your little group right there, Eddie, you could turn around. And I just want you to sort of talk about what did you learn tonight. And just dialogue, like, okay, let's figure out in our heads, let's use our brains, and like just articulate what we've learned tonight to each other. So just make it a discussion. What did we learn tonight?